we discussed about that nitrogen gas. It is a gas insulating material, and it is used as a cooling medium in our transformer. It is used as a fertilizer. Let's come to the insulating material that is called as a hydrogen. Hydrogen, it is a rarely used as an insulator. At normal temperature and pressure, it is a colorless, odorless, and tasteless. It reacts with the oxygen from the water, and it forms a H2O and hydrogen peroxide, that is H2O2. It is commonly used as a cooling purpose in electrical machine due to its lightness. Okay, it is a commonly used as a cooling purpose in electrical machine due to its lightness. Its dielectric strength is 2.5 to 4.5 kV per mm, kilovolt per mm. It is used in cooling purpose in electrical machine. It is used as a fuel. It is used as a prepare tungsten filament. It is also used for tungsten filament. SF6. What is the SF6? This is called as sulfur hexafluoride. It is a colorless, odorless. The electromagnetic gases have a high dielectric strength compared to the other traditional dielectric gases like nitrogen, air. Dielectric strength of SF6 is 2.35 times more than the air. More than 10,000 tons of SF6 are produced per year, most of which over 8,000 tons. So basically, you can say that it is a sulfur hexafluoride. Okay, sulfur hexafluoride gases means it is a colorless, it is a odorless, and it is an electromagnetic gases having high dielectric strength compared to the other traditional dielectric gases like nitrogen and air. The dielectric strength of SF6 is 2.35 times more than the air. More than 10,000 tons of SF6 are produced per year, most of which over 8,000 tons. Okay, so it is a gaseous intermediate. It is colorless, odorless. What are the applications that is the main important that is has sulfur hexafluoride? So SF6 is mostly used in a high voltage application, and it is used the most satisfactory dielectric machine like X-ray apparatus, Van de Graaff generator, voltage stabilizer, high voltage switch gear, gas laser, etc. SF6 bears some special properties follow. So we discussed that SF6 is a colorless, non-toxic and non-inflammable gases. It is a heaviest gases and has a low soluble in water. The gas can be liquefied by a compression. Its cooling characteristic is better than the air and nitrogen. Under normal temperature conditions, it is a chemically inert and completely stable with a high dielectric strength. This gas has very good electronegative properties. SF6 gas is a electronegative property. This is an important question that always it can from your exam that is the electropositive properties or electronegative properties. It is relatively large molecules have a great affinity of free electrons with which they combine and making the gas filament break much more resistance to dielectric breakdown. Carbon dioxide. Come to the carbon dioxide. What is the carbon dioxide? Actually, this is the carbon dioxide is a certain fixed type of capacitor. Carbon dioxide is used as a pre-integrated for oil-filled high voltage apparatus such as cable, transformer. The relative permeability of carbon dioxide is 1.000985 at 0 degree centigrade. Okay, and general properties of the insulating material. Yeah, come to the topic that is what are the general properties. So we discussed about the gases insulating material. First SF6, hydrogen, another is nitrogen, another is air. So what is this? These are the different types of your gases insulating material. So hydrogen, SF6, sulfur hexafluoride we discussed. That is the important long that is gases insulating, that is SF6. Carbon dioxide is used in certain fixed type capacitor and used as a pre-integrated for oil-filled high voltage apparatus such as cable and transformer. The relative permeability of carbon dioxide is up to this one at 0 degree centigrade, 1.0985 at 0 degree centigrade. General properties of insulating material. What are the general properties of insulating material? General properties of insulating materials. General properties of insulating material for a specific purpose use can be decided by knowing the different properties. So we have to know that exact requirement of the application. Okay, so that means the required properties of all be insulating material based on the use of different applications following properties. There are electrical properties are there, mechanical properties are there, thermal properties are there, and edging also there. And these are the different types of electrical properties. What are the electrical properties are there? Okay, so the insulating material used in electrical or electronic applications should be considered following. Okay, so insulation resistance. These are the ohmic resistance offered by an insulation coating, cover or material in an electric circuit, which tends to produce a leakage of current through the same with an increased voltage across it. Dielectric constant of permittivity. What is the permittivity? Permittivity, generally we use permittivity in insulating material varies with the temperature and frequency. In some cases, the material like HCl, H2O, CO, NS3 have permittivity variation with a change in temperature. Okay, this is the dielectric constant, or we can say that is the permittivity. So we know that there are different types of permittivity of a free space, permittivity of air. So dielectric strength, it is the maximum increased voltage bearing a capacity of insulator per unit thickness of material, up to which a current does not flow it. When come to the dielectric loss, this is the dielectric loss. Losses occur in a solid or liquid. Dielectric due to a conducting current, and the conduction current is due to the imperfect insulating quality of a dielectric, and is calculated by application of Ohm's law. It is in phase with the voltage and result in a power loss, that is I square R. In the material which is dissipated as a heat, that is dielectric hysteresis is defined as the lagging of electric force behind a electric force behind producing it. Under a varying electric force, a dissipation of energy occurs. The energy loss due to above cause is called as a dielectric hysteresis loss. The energy is dissipated as a heat. This loss gives an indication of the amount of energy absorbed by a material when subject to the acid strain. That means we can say the dielectric, all the insulating materials can be a dielectric, but all the dielectric materials cannot be insulating. That means for dielectric loss we are applying here. This is one we are applying here with supply voltage, that is AC supply voltage to the field, and there is a one diagram is that is the parallel resistance and capacitance are in parallel. Okay, so when you give a supply voltage the V, in case of current will flow, the current is divided into two parts. One is IR. IR will flow through your resistance part, and IC will flow through your capacitance part. So according to that, we will find that IR is equal to your total voltage, that is AC will supply the voltage V by R. According to your capacitor, we can find that IC is equal to V by XC. So this is known as a IR and XC we can find, and this is one derivation, that is P. You can find the power loss in case of dielectric loss. Okay, this is the plot against your IC and IP, and this is the angle, that is psi, and another angle is the del. I will clarify your doubt in next video section, that is dielectric loss. What actually what is the dielectric loss? Heating. This is also used in dielectric heating purpose. You can use, like we have a bad conductors like wood and etc. Bad conductors, like we have a different types of bad conductors, like heating purpose of bad conductors. We use this type of heating, that is called as dielectric heating. This topic is known as dielectric loss. So this is the dielectric loss, and we discussed that dielectric loss. So plot against E against IC, this is the versions of the dielectric material subjected to AC voltage. The leakage current does not lead applied voltage by exactly 90 degrees, as shown in a vector diagram and the phase angle is always less than 90, the dielectric loss can be calculated as